Hey everyone, welcome to part one of Rigid Body Movement Controller. This video we are going to look at how we can build a movement controller that's quick and simple for you to use in your projects. This should be able to be attached to any game object you want, and you can customize the controls, whether it's from a keyboard, a controller, or some sort of like AI algorithm that you create. This Rigid Body Movement Controller should work for all of that. So in this video, you're going to get a character moving like this. I'm using the keyboard. Up the top right, you can see my current speed. You can see whether or not we're grounded, and if I hold down the left shift key, you can see that we're sprinting or not. And then we can obviously jump. So without further ado, let's go ahead and get started with the code. If this all sounds interesting, please hit the like button, hit subscribe, and get notified when the next video comes out. Quick note, I did set up a Discord channel. Hopefully everybody can come and join. I've tweeted it out a couple times. I'm going to put the link to the Discord in the description below. But come join the community. I'm looking for any tutorial ideas, so I have a channel set up. If you guys want to post any ideas that you have or anything you want me to work on, I can do that here. I'm going to put in the announcements when I do release a video. If you have any questions, you need help on a project, either I can answer them or someone else in the community can come and answer them. I also have a devlog set up. I've been working on a side project that I'm actually going to be working on a video for later on a tennis game that I've been building, and I kind of update this devlog channel and take any suggestions in another channel if you guys want to participate in the development of that. But again, the link for the Discord will be down in the description below. Hopefully, I will see you guys there. All right, I'm in the project that you just saw in the intro, and I have a pretty much blank scene. I'm going to walk you through the setup of this movement controller just so you see how easy it is, and hopefully you can utilize it in your project. So basically, I have a ground piece here. It's a cube that I've extended increased its scale to 50 by 50. I put it on a layer called ground. By default, you don't have that layer, so you just click add layer, type in ground. Be sure to come back to it and then actually select the layer ground, otherwise it won't assign it. And then next, we're just going to create our player character. So you can actually attach this to anything you want. I don't have a player, so I'm going to go ahead and create one in the hierarchy. I'm going to right click over here, 3D object, capsule. I'm going to reset its position and then change its Y position to 1.5, which will put it on top. I'm going to relabel it to _player. And then all we need to do is add a component. In the component, the script that we're going to be creating today is called movement controller. So I'm going to add it. And right away it adds a rigid body for us. I'm going to freeze its rotation just so it doesn't flip around. And then I'm not going to change anything else on the rigid body. And then under my movement controller, there's a few things that we need to add to get started. If not, we'll throw exceptions. The first one is movement controls. So this is what controls our character, so where it gets input from. And this is another class that we're going to be writing today, but I have written one now. So it's called basic move controls. I'll expand it, and what this does, it just has a jump key and a sprint key, and then it automatically takes the horizontal and vertical inputs from Unity's original input system. I'm going to drag this component to this movement controls, and then under ground check, if you are going to be using a ground check, you need to put a ground check transform. So the way we're going to do that is right click our player, create an empty transform. I'm going to zoom in a bit just so I can position this properly on our character. Just lower it down a little bit, and I'm going to drag it to our ground check transform, and I'm going to actually relabel this as well, ground check. So now on our player, we have a ground check transform, which is the object we just created. We have our controls. I'm going to set our ground layer mask to ground and Control S to save and jump into Unity. And right away, our controller should be set up to move around, which it is, and we can jump. And if I hold down shift, we can sprint, which just makes us go a little faster. And that's working. So if the behavior is not exactly the same, one thing I do have differently than the default, if I go to project settings, my gravity is set to -75. That just makes it feel a little bit more responsive, a little bit more gamey, if you will. But that's pretty much it. So let's go ahead and jump into the code, and I'll show you how the movement controller works. So I'm in the movement controller script. This is the base script or base component that is going to provide or handle all the movement for our rigid body. And a couple things to note before we start and jump into the code. The first thing here is we require a component that's type of rigid body. So we know that we're going to be using a rigid body throughout this script, and so I'm just going to require it right off the bat. So if you just throw the movement controller onto the game object like I did in the intro, then you'll see that it automatically puts a rigid body if one does not exist. The other thing you're going to notice a lot in here is I have a lot of protected variables and a lot of virtual methods so that we can override them once we extend this class. So in this first video in part 1, we're going to look at the basics of it, and then in the second part, we're actually going to extend this movement controller to add custom functionality to it. And the protectedness, the protected variables and the virtual methods are going to be useful because we can override them when we extend the class. So again, rigid body, make sure that's up at the top. But let's go ahead and go through all the variables, and then we'll go through the methods that I do have written out. So first off, we have 3 properties here. We have isGrounded and isSprinting. Those are just to expose the protected variables so we have an idea of what the controller is doing, the state that the controller is in. And then we have current speed, which we're just taking the magnitude of the velocity of the rigid body that's attached to this game object. And those are our 3 properties. And then we jump into all of our serialized fields. These are all protected, and the reason why I use the serialized field tag here is if I did not, they wouldn't be exposed to the inspector and you wouldn't be able to edit them. But we want you to be able to customize and edit this, so we've added serialized field to them. The first thing here is movement controls. I'm not going to cover this yet, but no, this is a custom class that we write down below, and we'll get more into that later on in this video. But first we have base movement. So this is going to dictate our maximum base speed. So if our character is just walking, what does that speed look like? Then we have our base move force. So how much force are we going to apply in fixed update to get our character to move to this maximum speed? And then I have a variable here called stop slide speed. So in Unity, when you have a lower gravity, your character might look like it's sliding around a bit when you let go of controls. And to stop this behavior, at least in the project I was working on, I kind of wanted to stop it, or stop it sooner than it happens. I just look for a speed here, and once it reaches that threshold, I then set the rigid body velocity to 0, and you'll see that calculation later on in the script. The next part about the movement controller is we do a ground check. So we check to see if our character is on the ground. You can enable this using this boolean here, whether you want to actually check for ground or not. This requires a transform that we call ground check transform, which this is used, the position of this transform is used to cast a sphere below our player to figure out if we're touching the ground layer, which is this variable here, the ground layer mask. And then the sphere's radius, the ground check radius here, is just 0.25 units. Again, this is all customizable depending on what your needs are for your project. Then we go into the 2 movement functions. So in this base movement controller, this movement controller supports sprinting and jumping. It doesn't allow for multi-jumping. That's something we can add in the extended class, but it does allow it to jump at least once, and then it allows for unlimited sprinting, so as long as you're holding down whatever key that you assign to it in the movement controller, which again we'll get into in just a second, or the movement controls, excuse me. But here for sprinting, we have allow sprinting. Do we allow sprinting on this controller or not? Yes or no. And then we have a sprint speed, so we want this sprint speed, max speed to be a little bit faster than our base speed probably. And then we want to apply a little bit more force per fixed update when we're sprinting, right? So when you're pushing off, you're probably putting a lot more force down than you would normally if you were just walking. And this is what these 2 variables describe here. Jumping, again, a Boolean value. Do we allow jumping or not? True or false? And lastly, jump force. How much upward force are we going to apply to our character controller, or to our game object, excuse me, when we do jump? Lastly, we have a few private variables or protected variables here that we use. Of course, rigid body, we need a reference to rigid body. Our isGround and isSprinting properties, or excuse me, protected variables that we use for our properties that we expose, and then our current max speed and our current move force. So we use these to determine what we're currently moving at. And I'll explain that a little bit more down below. Excuse me. So the first thing here we're using monobehavior's awake method. I've left it private so you can't override it when you extend this class. And the only thing we do here is we capture our rigid body, and then we call first initialize. First initialize is a protected virtual method, so you can actually override it when we extend it. So that's good. So, and it gets called here in the awake method. So that's why you don't really need to expose the awake method here. But you can if you want, so you can definitely change this if you need to. But again, we get a rigid body component, and then we call first initialize. First initialize does a couple checks. The first thing it does, it sets our base speed. So we have reset base speed and force. If I scroll down to the bottom here, you can see in this method we're just calling setting our current max speed and our current move force to our base movement speed and base move force, which is defined at the top. Let's go back up to this first initialize method though. The first thing we check to see is if we have a move control script. So the move control script is used here to actually tell this script how the character should move. So if we're going to take input from an analog stick or a keyboard or some sort of AI, that movement controls script is what handles that. And so we throw an exception if we don't find it. So if we don't have this component on our character, we're going to throw an exception and say, hey, this game object requires this class. Make sure you add it. Otherwise, it won't run. If it does find it, then we're going to initialize the movement controls. And here I have just 3 events that we subscribe to, or we add a listener to. So we have a sprinting and jump method. And again, I'll explain this a little bit more when we get into the movement controls class. But just know that here we're initializing this class, and then we're going to subscribe to a couple events that are fired in that movement control script. Lastly, we check to see if we should be checking for ground, and if we are, do we have a ground transform? And if you don't attach a ground transform to that protected variable in the inspector, this is also going to throw an exception and let you know that this game object requires a ground check transform if should ground check is equal to true. Not too complicated. Now we have our fixed update. So this is set to protected. So if you extend this class again, you can override it, or you can rewrite it if you want. But here in fixed update, we have move and then physics checks. Move is the method that moves our character, and physics checks is a method that checks to see if we're grounded. So let's go into the move method because that's the bulk of this code. And the first thing we do is check to see if we meet that threshold of stop slide speed. So if this behavior is something that you don't mind or you don't care about or you're not experiencing, you can set this variable to 0 and it will basically, this won't ever run, or you can just comment this code out entirely and move on. But again, in one of the projects I was working on, I was experiencing this sliding behavior, as I call it, and I didn't really like it, so I clamped it down to set my rigid body velocity to 0 based on the threshold of stop slide speed. I think I set it to like 1.2 or something in my project, and it worked out well for me. But again, this is not necessary to actually move the character. This is just to stop a behavior I didn't like. So you can either comment it all out if you don't want it, or set stop slide speed to 0 and keep the functionality there for maybe a future project. But let's go ahead and actually move our character, and that's what I do in these 3 lines here. So the first thing we do is we calculate a speed factor, which is a adjustment factor based on the max speed that we currently allow, and it finds a percentage based on our current max speed and our current velocity, the magnitude of our velocity. And again, this just kind of creates a percentage that we multiply when we add our force to make sure that we never reach or we never exceed this maximum speed. Lastly, we have move direction. This is the direction that we're going to be moving our character in, and this is based on the movement controls move direction, which is a vector 2 in this case. It has an X and Y. And again, I'll explain this a little bit more, but basically in the basic move control script that I have attached to this game object, it's looking for a vector 2 movement or value, and that gets it from the keyboard. But you can actually get that value from like a controller or some sort of AI algorithm that you put together. And that's what's cool about this. It makes it a little bit more customizable. But basically we get ourselves a move direction. So let's say that this is a value between -1 and 1. And then we use the Rigidbody.Addforce, where we use this speed factor, so the factor to adjust our maximum force that will apply so that we can stay within this maximum speed. We multiply the speed factor by the current move force, which in this case at the start is our base move force, and then we multiply it again by our vector 2 move direction, or excuse me, vector 3 move direction, and this will add a force in the direction we want to move our character. And then the force mode is just force. So this isn't an impulse force, this is a constant force that we're applying every fixed update in the move method. And it's protected and virtual, so you can override it. So you can customize this movement if it doesn't fit your needs. All right, so moving on down, we have physics checks. This is just a quick method that just checks to see if we're grounded. Should we be checking ground, yes or no? If so, then let's run the ground check method. In the ground check method, we're just casting a sphere below us at the position of the ground check transform that you have attached to your game object in Unity. It's going to cast a sphere of the ground check radius, and it's going to check for collisions against the ground layer. And this value, or this line, returns a Boolean value, true or false, and we set that equal to is grounded. So if the sphere that's casted does hit a ground layer, it's going to set this is grounded to true. Otherwise, it will set it to false. Pretty simple. If you need a more complex ground check, again, this is set to virtual. You can override it and extend it to make it more complex and fit your needs. Here we have sprinting. So sprinting is called, in this case, it's called when we start sprint, and then we do something when we stop sprinting. But on start sprint, which is in our movement controls class, again, we'll get to that in just a moment, we call sprinting. What this does is just checks to see, one, are we allowing sprinting, and in this case, are we grounded? If that's all true, then we're going to set sprinting to true, and we're going to adjust our current max speed and move force to the sprint values. And then when we stop sprinting, here I just have action here where we just say, okay, we're going to reset our speed and set is sprinting to false. And then last but not least, we have jump. So a jump, when our character wants to jump, we check to see, again, if we allow jumping and if we're grounded. If both of those are true, we're going to add an upward force. So we're going to use Rigidbody.Addforce. We're going to add a new vector of 0x jump force y, which is a positive y value, and then 0 in the z-axis, so that we're not moving, on the horizontal plane. We just want to move up, and then our force mode is impulse, and that's all you need to actually jump our character. So that's the movement. This is the movement controller. Pretty simple for the most part. It looks like a lot more than it really is. A lot of variables that allow you to adjust what you need, but it's set up so that it's extendable, which again we're going to do in part 2. But for now, we're going to go ahead and check out the movement controls class and figure out how all that works and how it's connected to the movement controller. So here in the movement controls class, this is a abstract class. This is what allows us to provide some movement, or some abstract our movement control information away from the movement controller, and allows us to extend this behavior to add functionality, again, for a keyboard, controller, or some sort of AI algorithm that kind of controls how our character moves. This gives us the base starting point for that. So here I have an abstract class called movement controls. Abstract meaning that you can't just implement movement controls. You actually have to derive a class from this, which I'll show you in just a moment. It's pretty bare bones though. So at the top here, I have 3 events that return a system.action. And we have jump, start sprint, and stop sprint are the 3 that I have set up here. And then we have a public vector 2 called move direction, which, if you remember, in the movement controller, we use move direction to apply the movement vector for our character when we add force in the move method. The first thing, though, we have a abstract method called Initialize. So when you extend this class, or when you make an implementation of the movement controls class, you're going to have to provide a body for this method. And then we have 3 protected virtual methods here that just call the jump, start sprint, and stop sprint. It invokes those events. So here I'm just checking, does jump, if jump is null, yes or no. If it is not null, then we're going to invoke the event here. And you're going to see how I utilize it in this next class. So basically, I do this 3 times for on jump, on start sprint, and on stop sprint. We just check to see if the event is null or not. So basically, does that event have a subscriber? Yes or no. If it does, then go ahead and call the event and fire the event. But let's see how we can actually implement this. So at its basic setup, I have this thing called basic movement controls, which utilizes the normal Unity input system. So it takes input dot get mouse down, get key down, that kind of thing. So you don't have to use the new Unity input system. If you do want to use the input system, we're going to use it in the next video, and you can check out now on the screen for implementation and actually how to get that started. I'll put that in a card now on the video. But let's go ahead and jump in this class because it's pretty simple as well. The first thing we have here is we have public key codes for jump key code and sprint key code. This allows you to decide how you want what the jump key will be and what the sprint key will be. By default, I've set it to spacebar and the left shift key. That just made the most sense to me when I was putting this together. But again, this is exposed in the editor and you can edit it. And then I have two private variables here, horizontal and vertical. And these are going to be the values that we capture for that dictate our movement vector. So here we have that initialized. Again, in the movement controls class, it's set to abstract, so we need to override it and actually add implementation for it. Here I'm just setting horizontal and vertical equal to 0. And then I look for, we have a couple methods here. The first one is called jump input, and it's just looking to see if we push down the jump key. In this case, it's spacebar. If we do, then we're going to go ahead and call onJump. If you remember, onJump is the method that's protected in the movement controls abstract class, and there we're just invoking the jump event. So that's pretty simple. Sprint is very same setup. So here we're looking to get our key down, the sprint key down. Once that's down, then we're going to call onStartSprint. Once we let it up, we're going to say onStopSprint. And those two methods then are placed into the update method. So we're looking for sprint input and jump input. I've just moved them. I didn't want to clutter my update code, so I've just moved them into different methods outside. So if your jump input is a lot more complex, you're not going to crowd your update method. It'll be a lot more easy to read and maintain going forward. Lastly, we have our move input, which again is in our update method here. It's just looking for our horizontal and vertical axes, and I'm saying get the axis raw. And we apply those to our horizontal and vertical private variables that we set up the top. And then we set move direction, which again is the public vector2 that's in our base class movement controls. We set that equal to a new vector2, so X and Y, horizontal movement and vertical movement. And then again, if I go back to our movement controller, let me scroll up into our move method, you can see that we're using the move direction from our movement controls .x and .y to move on the X and Z axes. So that's pretty much it. So with these two, with the movement controls, we have basic movement controls, which again just takes input from our keyboard and our mouse using the old Unity input system. We have that in conjunction with our movement controller, and we have a simple rigid body movement controller that is, if anything, it's useful for testing and kind of getting your project up and running really quick. So let me know if you have any questions. Write down in the comments below. Otherwise, in the next video, we're going to extend all this and we're going to create a little bit more of a customized character controller that's going to add a little bit more movement capability, and you can kind of see where you can take this into your projects.